Hello and welcome to another video. Today we have an Asus B450 Plus on our bench. And this board came to me with unknown fault. So I got this in a job lot. I don't know what is wrong with it. I can already see that one of the RAM slots is kinda busted. It's kinda bent to the side. That might have happened in shipping, but I can bend it just back. We might need to resolder that. But what I was able to see at first glance is that we have a lot of scratching around the SIO area, if you can see right there. So I would guess that we will probably have missing components around there, and that this board won't start up. But let's start with just checking for resistances, because I do not know what else could be wrong with this board. Just to be sure. One probe on ground, bottom left, 3.3 volts. That is very low on 3.3 volts. We might 19 ohms. There might be a short on 3.3 volts. Interesting. Okay, so we will have to investigate that. 5 VSB has high resistance, then 12 volts has high resistance and 5 volts. Also high resistance. Let's see for 3.3 volts VSB. I checked that also always in the PCIe slots, and that has high resistance as well. Okay, so we do get a bad reading on the 3.3 volts, so we're definitely not going to be booting this board up. So we're not going to try to put 3.3 volts into there. I would say we first go under the microscope and have a look at the area of the SIO. Maybe some scratches or something there is responsible for that low resistance of the 3.3 volts. So let's first check that, and afterwards we will probably have to inject some voltage into the 3.3 volts in order to find out why the resistance is that low. But let's first go under the microscope. So here we are. This is the damage I was talking about. It starts at the Ethernet controller, I think this is. That resistor array has gotten a little bit of a hit, but I don't think anything here is that much damage that it would need to be repaired. Don't think this is actually bad. Let's continue on. I think all of these traces are fine still. They look awful, but I don't think that they are broken anywhere, to be honest. Let's further see here. So as bad as it looks, I don't actually think that there's anything wrong with this area here. We might need to check if some of these small traces, like here or there, are broken, but I don't think so. I think this area is actually fine. So let's have a continuous look then around the CPU socket just for broken components, just to be sure, while we're already at it. I'm going through this quickly in order to see if anything's broken. That one resistor looks like it got a chunk out of it. Yeah, it looks partially hit, but I think it should be fine. It is that one right there. Let's further see if anything got hit or damaged anywhere. BIOS chip. Oh, this is a Giga device chip. You see these very rarely on boards. But so far so good. Nothing. Oh yes, a little bit of damage here, as you can see. So if you see this resistor right here, this got hit a little bit. And this one there also, but they're still all there. So they're in a state where I wouldn't think that they are problematic, and where they lost their resistance and went high resistance. Yeah, so far so good. Okay, so I don't think that is going to be a problem for ourselves here with this board. So we will have to investigate further the 3.3 volt short, or almost short, that we have. Let's go. This is now at the bottom of the board. I want to see for the area where 3 VSB is being created. But 3VSP wasn't shorted, so I don't think that is a problem for us actually. Let's see if we can see anything obvious that is like charred or burned that could be related to the 3.3 volts being low resistance. But so far it looks very good. Okay, I don't think there's anything knocked off anymore. At least not for the front side. We could switch to the back. There's on like lower end boards, there's very few components on the backside, but they can be important. So it's a quick check. This, for example, is behind the PCH. And let's see for behind the CPU socket. Also looks to be fine. And I don't really think there are any more components here to check for us. So let's now then go for the voltage injection, because I do not want to turn this board on before checking what the 3.3 volts is actually, why it's so low. So we're going to start with the lower voltage. I'm not going to start with instantly 3.3 volts. I want to see how much current it will take. So we're going to start with 1.7 volts. What I always do is I connect my power supply to a ground. For this example, I use the DVI, and then I use something that I can inject voltage with. In this case, I take this pick, and then I'm going to insert it. And at 1.7 volts, we have 140 milliamps, which is not that much. Okay, let me go for 3.3 volts then, and see how much that takes. 650 milliamps, that is actually not that much. 650 milliamps might be fine, but I want to monitor this under a thermal camera just to be sure. So let's see for that again, if I can find anything that is shorted here. So 650 milliamps is being drawn, and the only thing that is heating up is our SIO. Something else heating up there, something small. This, yeah, I think that is a small MOSFET. But yeah, it's the SIO that takes quite some amperage here. We will have to see. It should have its own regulator somewhere, and we need to see if that is also shorted, if that like has lower resistance. So we're still in resistance mode. There's a regulator right here. Let's see if that is... No, it doesn't have low resistance. Yeah, interesting. So this SIO might be faulty actually, but it might not be. We will have to see. We might not have a reaction to the power button because of a dead SIO here. I'm not too sure about the resistance. Like 20 ohms is really low. Like, or 15 or whatever we saw. That is like so low to a point where I'm not too sure if that can be right. But let's find out. Nothing else for us to do but to plug this in. Put a CPU into here. Let's start with my favorite 2200G. And see if we even get a reaction to the power button here. Oh, that is good to see. While pulling the latch, it pulled the socket cover. Okay, we will have to take a look at the socket, if that is still fine or not. So, it seems like... Okay, that is just dirt. Let's get that out of here. We have a little bit of charring here, and whatever was tried with this one. This looks like someone tried to replace this maybe. But the rest of the socket looks fine. We will have to know what that especially one is for. But we can, I think, just put back the cover for this. Just pop it onto here. And try out to use the socket as it is. So let's put in a CPU, push firmly down on it and clamp down. So, and to see if the socket actually still works, let's do a quick test for the data lines of the PCIe, for example, in order to see if we not waste our time here. We're going to need this small tester, Chinese tester, that takes 12 volts in order to check the data lines connection from the PCIe to the CPU. So let's see now. Yeah, that looks fine. So all of the connections are there. I don't think that the socket will be a problem. We're not going to check the DDR now. I'm just going to think that it is fine because the socket looked fine. And yeah, we had one test that looks good. Let's just see how this board now behaves. Let's plug in some RAM. And let's also get a power button and a speaker into here. I got to be honest, I kind of don't think that this will react to the power button, but let's see. So let's see for our power consumption. We have 130 milliamps. That looks very fine actually. Let's see if we react to the power button. We do 500 milliamps. Okay, so 500 milliamps. Oh, the SIO gets hot. Oh, it gets burning hot. Whoo! Oh yeah. The SIO gets really hot. Never mind, it is dead. Let's see once more with the thermal camera. So let's have a good look here. When I turn this on, the SIO doesn't get hot, but have a look when I press the power. Oh wait, so let's have a good look right here. As soon as you press the power button, do you see that heat spot? That is very hot right there. That is so hot that I can't touch it with my finger. So yeah, this SIO needs to be replaced here. So I probably won't have the chip. I probably will have to order it and wait like 2 weeks for it to arrive. But I will see in my stash if I have this. Let's see under the microscope what we actually need. We need an ITE chip, and let's see. IT8665E. That's what we need. Well then, I'm going to order one of those, and then we're going to see each other again if I have that SIO. So I was able to source an SIO for this. So it took some time, but we got it off AliExpress, and let's hope that this will now work. Important is to look at the orientation. In this case, it's very easy. It's just with the writing facing up. And what I will be doing now, let's get the preheater out. So what we're going to do is I will be applying flux all over the chip, all around it. And I want to apply leaded solder on all of its pads so that it can remove easier. The preheater is now set to like 250 degrees, but the board will never reach 250 degrees with that setting. The board, I think, will reach around 100 degrees, so it won't get that hot. Putting leaded solder on, having the board preheat. So, because you have seen me in one of my latest videos do exactly this, I will probably fast forward the rest of it. So I will be taking it off with hot air, and because it's preheated, it probably will be very easy. Then I will be cleaning up the solder parts and then placing the new chip and drag soldering it on. Cue the music, I guess, and the soldering montage of this. So this SIO sadly soldered awfully. If you've seen that before, when you buy off of AliExpress, there's varying quality of chips that you get. And this one instantly oxidized on all of the pins that were on there. So it made big problems with drag soldering. Sometimes you get chips like that, sometimes you get chips like that. Like the ITE chips that I put in onto here, it seems like that they are all taken off of other boards. So this definitely wasn't a new chip. This was a taken off chip from something or somewhere, and then it was sold as new. And all of the pins were good, but instantly while soldering you notice that the chip was used before. In one of my videos, in my previous videos, I soldered an SIO onto an MSI board, and that was a Nuvoton, and that one soldered perfectly. That one felt like a new chip, and that probably was a new chip. And this ITE chip probably is a used one that was taken off of something, and that is why it soldered so badly, because most of the time these come from China, and they overheat the chip massively, or the board massively, and then they clean them off in an ultrasonic cleanout. All of those things just add up and make it worse to solder these on. Same thing often happens with SIOs, with chipsets, if you get them from there, that they are really, really difficult to solder on. I hope that this time I actually got it on properly now, and that it will work. It might be that I will have to go over each individual pin, just do the tweezers test and see if they are solidly on there. But let's first try it together if any of what I've done has actually worked. So before we had way too high power consumption, and we were shorted on 3.3 volts. I think it was 3.3 volts that we were mostly shorted. Let's check that with the multimeter now. In kilo ohms range, I would expect like, what, 10 kilo ohms maybe? Nah, maybe, probably less, like 2 kilo ohms maybe. Still only 200 ohms, that is very little. So that is not much of ohms on the 3.3 volts side. I expected more. But okay, but it isn't shorted anymore like we had before. So let's then get the passive power consumption into here. Let's get also a power button and a speaker on. So let's see now. So we have 130 milliamps. That looks very good. And now we have the lighting off also. The SIO is not getting hot anymore. Let's see. I do have this postcard right here that we can use. So let's see if we get postcodes here. Let's get the light out of here. Let's see. Reaction to the power button. Reaction to the power button. That's good to see. 1.6 amps. Question now, do we go any further than that? But we do not. I do not feel... Is the CPU getting warm? I feel like our BIOS isn't initialized. No beeps, nothing. I see a reset and then go off and on. So we probably have to take a look at the BIOS chip and flash that. And you can see at the power consumption that it goes low and then high again. Okay, let's, before we go over to flash the BIOS on this, let's see if a different processor on here will make a difference. So let's try 2600. So let's see if a different processor can make a difference. It's higher power consumption, but I don't think we're booting. Yeah, we're still resetting, as you can see. So it goes to lower amps or even higher amps. Yeah, we go to 1.3 amps and then up again and lower. So we probably have to flash the BIOS on here. Because the CPU is getting warm, I think we have all the voltages that we need. Just that the BIOS seems to be not good on here. So let's go under the microscope and see that the BIOS is properly here, if that has been flashed or not. So the BIOS chip looks like it has been soldered. So that might be the reason why we are not getting anything here, that there's a wrong BIOS on here. So let it solder onto here, and let's solder this chip onto an adapter board in order to connect it to our programmer. So let's take the chip out, put it onto a adapter board, and then hope that the BIOS will solve our issue here. So we got our BIOS chip. Let's now read its content, and yeah, let's hope that someone has done the wrong BIOS onto here. So let's get a proper BIOS. So this is the read out content, and it's weird because it starts from the very beginning. That might be fine, but that might also be not fine. We will see. So what to do with Asus BIOS files? You need a tool that is called UEFI tools. You use that cap file, put it into here, and click on, open it up, click on the UEFI image, extract as is, and then save it where you want it. And then you have the actual BIOS file that you want to flush. As you can see, it's a little bit smaller than the cap file. So now we go into the programmer. We're going to be saving the original BIOS from it, just in case. Now we're going to open up that extracted image, and it looks completely different. It doesn't start at the beginning. So that might be that someone forgot to convert the cap to the bin file. So this might be our hope here. So let's write that buffer to the memory and hope that our board will then start to work. So the chip is now verifying, and I'm positive that this will help, and also I'm just hoping that it will do this board good and that we're actually now able to boot. So verification is good. Let's get that chip now back onto the board. So the chip is on. Not too beautiful because there's a lot of solder, but yeah, it's attached properly. And yeah, let's hope now that it will actually work and boot up. So let's see now. We have 150 milliamps. Before we do that, let's get the post card also into here again to see for postcodes. Now we should we have now more power consumption, but let's see for the press of the power button. Let's do it together. And 2.3 amps, that looks very good. And now we have running postcodes also. That is very, very good. We should be, it's on a DRAM LED currently, I think. Or is that a VGA already? No, that's a DRAM LED. Yeah, and there it's going further, turning off, and now it should be turning on again by itself. There it is. Let's put a cooler onto here. And it's complaining about VGA because there's a 2600 in here right now. That is very good to see. So let's get the 2200G in here again in order to get a VGA output. So let's turn it on and let's see. Give me that post screen. So we're done with this board. Turned off, and now it should turn on by itself. There it's turning on. 4 amps, beep, and there's a post screen. There is the full-sized post screen of this board turned on. Resetting by itself. So, BIOS screen. There's the BIOS screen. And to test it properly, we want a GPU into here with a processor that doesn't have the integrated graphics. So we're swapping back to the 2600. And we're going to put in the GPU into here so that we confirm that the PCIe slots are working fine. Also, what we want to try is that the M.2 is working. M.2 is working. We get all of the DDR into here because the socket, as you saw, the cover kind of went off of it. And now we're going to try with a GPU in here with all 4 DIMMs of RAM. Okay, I didn't like all of the RAM. Let me do some replugging in order to get all of the RAM to work in here. So it's actually been over an hour. And I've ran into a very interesting problem on this board while trying to set this up. As soon as you go over 2 sticks of RAM, the board does not want to start anymore. It's always restarting them and cycling. And it doesn't matter which DIMMs I use. I've used all 4 that I have in different orders, in different combinations, in different slots. all of the slots work individually, and all of the slots work in combination of two. But as soon as you plug a third one in, it doesn't want to work anymore. So you can even get dual channel, like I have right here. I have currently this one and this one in, so the second or the fourth. But as soon as you try to get a third stick into here, it won't work anymore. What I've tried is I flashed the BIOS via the board itself and put the newest BIOS on there. I've resorted the SIO completely, so all around I went over into each individual pin to make sure that it is sorted properly, and that also didn't help. So yeah, I went around looking for missing components, and I also didn't see any anymore. I went to the spot that we had with all the scratches around the SIO, and that also didn't. There's nothing broken there as well. So yeah, I'm currently just seeing what I can get. Like, I'm going to see if there's like chipset drivers or something like that I can install, but that shouldn't really matter. Like, all of the USB is working, the audio is working, the Ethernet is working, everything is working on here, except multiple channels of RAM. So if you have any suggestion what that could be affected by, please leave it down in the comments. The only thing that I could think of is maybe the SIO is faulty, partially faulty, and yeah, I just got a bad chip, but I think that's highly unlikely with everything else working so well. Yeah, I just don't know what is necessary for more than two sticks of RAM working. Like, I've checked all of the RAM voltages. I used the RAM tester, the RAM voltage tester that we have, and put it into the slots as a third one, and all of the voltages are there, they're working. And yeah, I do not know why that isn't working, but because I have no idea and don't know where to go from here, and there's no firmware for a BIOS, for an controller as far as I know here, I will leave it at that. And I will thank you for watching this video. All of my tools, as always, are linked in the video description. If you want to get your own current meter for measuring the power consumption, you can email me. The email is linked in my video description about acquiring one of those. And all of my tools are linked in the video description. And thank you very much for watching, and goodbye.